Okay, guys, I want to talk about some multi-step equations here. The worksheet that you'll be getting possibly today or tomorrow will be on multi-step equations, and the one you'll get will have fractions on it. So I wanted to go over some things to do when you have fractions. Now, with some of the classes I had talked about what to do when you have fractions, you always want to leave the variable for the end when you're solving equations, but at the same time, if you have fractions in more than one place, there are certain things we can do to possibly get rid of the fractions altogether. So we're going to start with this first one here, and because you see that 3x is on top and you have a 5 on bottom, but then it's also adding 4/5 to it. You see that you have like common denominators already on bottom, all right? But instead of going ahead and adding these together, possibly a little bit easier way of doing this would be to use this common denominator here and get rid of the fractions altogether, all right? So in this case, what I want to do is multiply, since whenever you see that this is being divided right here and right here, the 5 is being divided, we want to multiply or do the opposite to get rid of the 5. Alright, and we would do that. Here's the thing about this: anytime you do this, you got to do it to both sides of the equal sign. It just so happens in this problem, though, that I have two different fractions on the left side. So I have to multiply that 5 by everything on the left side and also on the opposite side of the equal sign. So the easiest way to remember this is just multiply by that denominator to everything across the board, okay? To all the terms there, okay? So in this case, this is how it works. So I'm saying I'm going to multiply by 5, and technically this is what I would be doing. 5 times 3x would be 15x over 5. Well, if I reduce 15 over 5, I end up getting 3x, okay? Well, a little bit easier way of doing this, to skip all the process there, would be to think of it like this. How many times does 5 divide into 5? Well, it divides it one time. We'll take 1 and multiply it by 3x. Well, 1 times 3x is 3x, okay? And what it does is it eliminates the fraction altogether, all right? So let's put our plus sign down, and let's go to the next one. 5 will divide into 5 one time. 1 times 4 is 4. And then 20 and 5. Now notice there is no fraction here, okay? There's no fraction bar. So just take 5 and multiply it by 20, which would give you 100, okay? So now, let me just review just a second. I took 5, divided it into this 5, which it went one time, and then took 1 times 4, and that's how I got 4. I did not do that on this side because there was not a fraction with the 20. The 20 was sitting there by itself, so I just took and multiplied 20 and 5 together, all right? Now I have a problem I can solve. So we always talked about leaving that variable to the end, so I'm going to subtract my 4, and that leaves me with 3x equals 96. Divide both sides by 3, and x equals 32. Okay, and you could plug that right back into the problem, work that out, and get your or find out that you are correct. Okay, you could check that problem. All right, let's look at the second one here. Now I'll zoom back out here in a second. On the second one here, notice I have one fraction, and I don't have a fraction here or here. All right, but this still applies that to get rid of this 5 right here, I'm going to have to multiply by the 5 on bottom and do it to everything. Okay, so just like we did before, over here we multiplied by the 5 at the top, wrote it at the top. We're going to do the same thing here. All right, now 5 divides into 5 one time. 1 times 3x is 3x. All right. Now, there's no fraction with the 17. So all I need to do is say 17 times 5. All right. So let me pull my calculator out here. And 17 times 5 is 85. So I would write down plus 85. And then we know 20 times 5 would be 100. Okay. All right. Now, we're back to the same problem we had just a second ago with right here, 3x plus 4 equals 100. Same steps here, same process. I'm going to take and subtract my 85. All right, so if I subtract 85 from 100, I end up with 3x equals 15. All right, now I can divide by my 3, and x equals 5. Okay? All right, now, if you look at number 3 is a little different because number 3 has 2 different fractions involved. All right. So when you have 2 different fractions with different denominators, we have to find that common denominator. So in other words, we need to find something that will that's at least as big as our biggest denominator rather, which would be 4. And it's got to, both numbers 2 and 4 need to be able to divide it into that number. All right. Well, a common denominator of 2 and 4 would be 4. All right. So I'm going to use 4. And again, we have to multiply it by everything. So now let's take 2 and divide it into 4. 2 divides into 4 2 times. 2 times x, remember this is an understood 1 right here, okay? So 2 times 1x is 2x. All right, 4 times 1 is 4, so plus 4. Then I have 4 divides into 4 1 time. 1 times 3x is 3x. And then that all equals 4 times negative 9, which is negative 36. Okay, now I have some like terms I can combine. So I've got 2x plus 3x, which is 5x. Bring down my plus 4. Bring down my negative 36. All right, subtract my 4. So 5x equals negative 40. And then the last step would be to divide by 5. So x equals negative 8. All right.